Hello, Assalamualaikum warahmatullahi wabarakatuh. Today my friends and I are going to talk about something really interesting that we often see in movies and military documentaries. It is night vision. So before we start, I'm going to give you some facts about night vision. Night vision works because of infrared radiation technology. With this technology, we are able to see things in the dark that our eyes normally can't see. It helps soldiers, police, and even wildlife researchers to work safely and effectively at night. I hope by the end of this presentation, you'll have a better understanding of how night vision helps us see the unseen. So, this is the contents that we include in our presentation. We have introduction to night vision, types of night vision devices, significance of night vision, relevant to scientific instrumentation, application of night vision, detailed exploration of night vision. And then we have real-world implementation of night vision, benefits of night vision, challenge in night vision, future development, and lastly the conclusion. Now, I'd like to introduce my group members who worked hard on this presentation. We have Nurliana Afika binti Azmi, Irdina Zarid Sofia Jailani, Nuri Marhanis binti Muhammad, Muhammad Endril Haziq bin Muhammad Adillah, Muhammad Aiman bin Muhammad Jafri, and lastly we have Muhammad Aminuddin bin Zainuddin.
Okay, so first let's start with introduction. Night vision technology has made it possible to see clearly in the dark by using infrared radiation. This type of radiation is actually heat that objects and living things give off, even when there's no visible light around. Night vision device pick up this heat signal and turn them into image we can see, allowing us to navigate or observe our surrounding in total darkness. It's a technology commonly used in the military, security system and wildlife monitoring and emergency rescue operation. Thanks to ongoing improvement, night vision tools have become more accurate, easier to use, and available in a wider range of fields.
Next, we move on to significance of night vision and his safety. First, night vision boosts safety. It helps military, police, and rescue team navigate and operate in the dark, saving lives during nighttime mission. Scientific discovery. Second, it drives scientific breakthroughs. Technologies like CMOS sensors and photon counting detectors enable high-resolution imaging for astronomy and precise measurements in biology. Think about capturing stars or studying cells in low lights. Wildlife and environmental monitoring. Third, it supports conservation. Night vision let us study nocturnal animals and monitor ecosystem without disturbing them, protecting our planet. Technological advancement. Finally, it fuels innovation. From aviation to medical research, advanced sensors in night vision push the boundaries of what we can achieve. Now, I will talk about relevant to scientific instrumentation. First, CMOS sensors. CMOS sensor is a high sensitivity camera that captures crystal clear image in near darkness. In astronomy, they help us observe distant galaxies and stars with amazing details. In biology, they power live cell microscopy, letting research watch cells in action without disturbing them. It's like giving science a night vision superpower. Next, photon counting detectors. Photon counting detectors take precision to next level. This device detects individual photon, tiny particle of light, making them perfect for cutting-edge fields. In quantum physics, they unlock experiments at the atomic scales. In spectroscopy and in spectroscopy, they analyze material with incredible accuracy, opening doors to new discoveries even in the darkest condition.
Okay, now let's move to application of night vision. We have three applications. First, military and defense. So night vision is widely used by armed forces for surveillance, navigation, and combat operation in low light or nighttime conditions. It helps soldiers detect enemy movement and operate effectively without revealing their position. Second, security and surveillance. Night vision cameras are used in security systems to monitor homes, businesses, and public areas during nighttime. This allows for 24/7 hours surveillance even in total darkness. So last, we have wildlife observation and research. Researchers and nature enthusiasts use night vision devices to study nocturnal animals without disturbing their natural behavior. It's also helpful in tracking wildlife activity in remote or low light environments.
How night visions work. First, light source. Night vision gadgets work by collecting a boosting small amount of light like moonlight, starlight or infrared light. Second, image intensification. Light enters through a lens, it hits a surface called a photocator which changes light into electrons. These electrons are multiplied to make the image brighter. The electron hit a phosphorus screen which turns them back into visible light, creating the green image we see. Third, infrared illumination. Some devices use infrared IR light which is invisible to our eyes to help see in total darkness. Types of night vision device. First, image intensifier tubes, common in night vision goggles and monoculars, mostly used by military. Second, thermal imaging, detect heat, not light, useful for finding people or animals in total darkness, often used in military security and search and rescue missions. Third, we have digital night vision, uses sensor to read light, including very low light, can take photo and video, often found in modern consumer night vision gear, like what you buy in stores.
Next, I'll be sharing about real-life implementations of night vision technology. First is exploration and planetary rovers. NASA's Mars rovers and lunar landers use thermal and low-light imaging to navigate dark extraterrestrial surfaces. Night vision helps identify heat-retaining rocks or subsurface thermal anomalies on Mars or the Moon. So, by detecting heat differences, we are able to see the planets at night. Second, bat-inspired research in bionavigation. Night vision is used in studying nocturnal navigation and hunting techniques of bats and owls. It also helps develop bio-inspired autonomous systems for drones or submarines navigating in complete darkness. And lastly, military night operations. Night vision enables soldiers to conduct missions in total darkness, including raids, patrols, and reconnaissance. It also enhances stealth, target acquisition, and survivability in low-light combat environments. Next, benefits of night vision technology. Have you ever wondered, in what way does night vision technology benefits us? First, it enables vision in darkness. The night vision technology allows humans to see clearly in low light or total darkness without external light. It also supports activities at night without compromising safety or efficiency. Second, it improves safety and awareness. This is because the night vision technology reduces risk of accidents, injuries, or ambushes during nighttime activities. It is also useful for drivers, hikers, emergency responders, and workers in dark environments. Third, it enables 24/7 functionality for security systems and emergency services as it reduces dependence on daylight or artificial lighting. And last but not least, the night vision technology is versatile and adaptable as it can be integrated into goggles, scopes, cameras, vehicles, and drones. It is also used across diverse fields including transportation, research, and public safety.
Hello everyone, today I'd like to talk about some of the challenges in night vision technology. First, there's the signal to noise ratio issue. Because night vision works in low light, the signal it gets is quite weak, and there's a lot of electronic noise. This makes image less clear and affects how well the system can detect objects. To fix this, we need better low noise sensors and advanced image processing. Next is power consumption and portability. High-performance night vision devices use a lot of power. This makes it hard to use them for portable, remote, or long-duration applications. So there's a big push to design more energy efficient sensors and processors. Finally, there's the issue of cost and accessibility. Advanced night vision like thermal cameras and high generation image interspheres are very expensive. This limits their use in civilian, medical, and commercial fields. To help more people across this technology, we need to create affordable and sensitive sensors like CMOS and InGas. And now, let's go to future development of night vision technology. First, we have smart AI-powered night vision. Future night vision devices will use artificial intelligence to automatically detect, track, and recognize objects, animal, or people in the dark. And then we have improved image quality and color night vision. Next-gen devices will offer higher resolution and possibly even true color night vision, not just green-tinted views. That's all from me.
Now, I will continue the presentation with the conclusion. Infrared radiation technology works by using heat and electromagnetic waves to see things even where there is no light. This is what helps its night vision device work that can change heat into image we can see in the dark. This technology is based on physics and is very important in many areas like the military, safety, wildlife observation and rescue mission. As time goes on, this device keep getting better, easier to use, and more affordable. This shows how science help us solve problems in real life and improve our daily life.
So before I end this presentation, I would like to say thank you. First, thank you to our teacher for giving me the chance to share this topic. Second, thank you to all of you for listening patiently. Third, thank you to my friends who support me while I prepared this presentation. I hope you all learned something new about night vision and infrared technology. Thank you once again.